This is question 33 from the June 2015 Algebra 1 Regent. Albert says that the two systems of equations shown below have the same solutions, and then we have a first system and our second system. Determine and state whether you agree with Albert and justify your answer. To answer this question, we need to solve the first system of equations and the second system of equations to see if they have the same solution. Let's start with the first system. We can either solve it graphically by rearranging it into y is equal to mx plus b form and then plugging both equations into the calculator, or we could solve it using substitution, or we could solve using elimination by addition. Let's use elimination by addition. But notice that our equations, if we would add them together, 8x plus 9y is equal to 48 plus 12x plus 5y is equal to 21, that would not eliminate any variables. And the point is, to do elimination by addition, the point is we want one of the variables to fall out when we add the two equations. So we're going to have to rewrite these equations. If we multiply the whole first equation by positive 3 and the whole second equation by negative 2, then the coefficient of x in the first equation is going to be positive 24, and the coefficient of x in the second equation is going to be negative 24. Therefore, when we would add the two equations, positive 24 plus negative 24, the x's would cancel out. So let's rewrite the equations. 3 times 8x is 24x. 3 times 9y is 27y. 3 times 48 is 144. And then the other equation. Negative 2 times 12x is negative 24x. Negative 2 times 5y is negative 10y. And negative 2 times 21 is negative 42. Now let's add these two equations. 24x plus negative 24x, those two cancel out. 27y minus 10y is 17y. And 144 minus 42 is 102. Now let's solve. We have our equation with just one variable, and we can solve it for y. Divide by 17 and divide by 17. Y is equal to 102 divided by 17 is 6. So y is equal to 6, and let's solve for x. To do that, we can plug in our y value that we found into either the first equation or the second equation. Let's use the first equation. So 8x plus 9y is equal to 48. And then we have a value for y. So 8x plus 9 times y we know is 6 is equal to 48. 8x plus 9 times 6 is 54 is equal to 48. And we can solve this for x. Minus 54 and minus 54. 8x is equal to 48 minus 54 is negative 6. Divide by 8 and divide by 8. X is equal to negative 3 over 4. That would be the x-coordinate of the intersection of these two lines. So the coordinates at which these two lines intersect is negative 3 over 4, comma 6. Let's find the solution to the other set of system of equations. In this one, we can solve it either graphically by rearranging it for y and solving on the calculator, or we could use elimination by addition, or we could use substitution. In this question, for this system, it's going to be easier to use substitution because notice that the second equation, it has no x. Negative 8.5y is equal to negative 51. So it's very easy to just solve this equation for y. Divide by negative 8.5. Divide by negative 8.5. Y is equal to negative 51 divided by negative 8.5. Positive 6. And now that we have a value for y, we could plug into the first equation that does have an x and solve for x. So 8x plus 9y is equal to 48. And we have a value for y, so 8x plus 9 times 6 is equal to 48. 8x plus 9 times 6 is 54 is equal to 48. minus 54 minus 54. 8x is equal to negative 6. Divide by 8 and divide by 8. X is equal to negative 3 over 4. Notice that we have the same x and the same y as before. The point of intersection of these two lines is negative 3 over 4, comma, positive 6. Notice it's the same as before. So the answer to this question is determine and say whether you agree with Albert. So yes, we do agree with Albert because he says that the equations below have the same solution, and they do. Justify your answer. The solution to the first system is negative 3 over 4 comma 6, and the solution to the second system is also negative 3 over 4 comma 6.